Good morning. Welcome to the work and power lesson. So, today let us concentrate on the work first. A work is done only if an object moves in a direction parallel to the force. So, work is a scalar quantity and we calculate work using the formula W is equal to W is equal to F times delta X times cos theta. Now theta is the angle between the object, between the force and the direction of displacement. So if the object moves in a direction parallel to the force, then the angle is 0. So the maximum work is done when the object moves in a direction parallel to the applied force or net force. Okay, so consider an object moving on a rough surface. Let me say an object is pulled to the right or to the easterly direction on a rough surface, then definitely the frictional force will be in the opposite direction, that is west, towards the west. And as you can see, there are four forces acting on it. Applied force to the east, frictional force to the west, force of gravity downwards, and normal force upwards. So let us calculate the work done by all four forces separately. So you can see the work done by the applied force is a Fa times delta x times cos theta. So in this case, the object moves in a direction parallel to the force, and you know that there is no angle between parallel lines. Therefore, theta is equal to 0 and cos 0 is equal to 1. So that is how we calculated the work done by the applied force. Now look at the work done by the frictional force. You can see that the object moves to the right, but the friction is in the opposite direction. So you can see the angle between those two forces are 180 degree. And you know cos 180 is negative 1. Okay, now let us look at the vertical forces. So normal is perpendicular to the direction of motion. Likewise, force of gravity is also perpendicular to the direction of motion, downwards. And you know that cos 90 is 0. So can you see that? So the forces acting perpendicularly are not doing any work. So let me remind you one thing. So when we carry a heavy school bag or a heavy textbook, actually you are not doing any work. Let me give you an example. So Naledi carries 5 kilograms school bag and she walks 50 meters straight to the physics class. How much work is she doing? So if you use the formula, the force due to the bag is actually the weight. So the weight of 5 kilo bag is now 49 Newton, as I have indicated here. So the work done by her is actually W is equal to 49 times 50 times cos 90, because the weight of the bag is perpendicularly down and she walks straight in the horizontal direction. So the theta is 90 degree and she is doing 0 joules of work. So let me remind you, you usually complain that the bag is heavy, the book is heavy. Actually, you are not doing any work. So scientifically, you have no right to complain. Well, if somebody carries a load to upstairs, he or she will be doing a work. For example, if you go to Mr. Mapoto's class, definitely you will be doing a work because you are lifting the object against gravity there. Okay, let us look at another simple example to make the concept very clear. So think about an object pulled to the left or westerly direction with the 10 Newton force, and consider it moves 3 meters. At the same time, this is a rough surface, therefore there is a kinetic friction which is 3 Newton eastly. You know that friction is always